Welcome again. So we continue with the second technology, that's a non-thermal one, like a ozone technology, which is used for again for the fresh produce quality and safety side. So what we're dealing actually all about non-thermal techniques, okay, which towards the food safety and preservation. So we starting with the ozone, and as we come now the non-thermal one, whenever we're discussing from the last 3 days, that's what people like, because in whole scenario you realize one thing here at the end: consumer is the king, what he expect, okay. And at the same time, when we see the post-harvest losses magnitude, looking for high losses and increasing the population, the idea here, we have to be some techniques, green technologies, okay, or environmental friendly technologies, which is helping here to reduce the losses, at the same time maintain quality and have the enough product. Or when the population, when we estimated that in 2015 growing by additional 2 billion people from today. So idea here to how much we can preserve the quality product for them. So whatever the human consumption we can see for the products, we have the sources for our energy, including protein, nutrient, it coming from the fresh produce, fruits, vegetable, and even sometimes we can go beyond for the food product, because the ozone, when we're talking about ozone, we have the application even the grains, cereals even, okay, even with that fruits and vegetables, we can found nowadays the application in the cereal part actually. So when we took for the magnitude losses, and still the consideration is that one, fresh products have the maximum losses, okay, maximum losses. And the idea here, with when the population is growing and keeping the product for the them, alternatively we need to increase production, but alternately we have the limited land now, because every time we get decreasing. And the another one, it's supposed to be linked your production improvement when we look for the basic agriculture side, when the biotic and genetic changes happening, even the modified foods. But link is supposed to link with the ignored things, that's a post-harvest actually, where we able to maintain the product and availability of the product for the people throughout the year, and it may make towards the achieve the food security for this one. So when we look for the preservation side, preservation, when we talk here, not a new thing. Even our forefathers know that operations, okay. Even if you see our grandfather, if you ask, they have the techniques. Sometimes our drying, even the pickling and other operations, they are doing that one. Preservation, they are doing loading in the slow temperature. Even sometimes some traditional practices just covering the fruits with just avoid oxidation and preserve the food for a longer period. So idea here to challenge here, to look for the technique that may be environmental friendly, best for even economic better, and at the same time without compromising the quality of the product. So that's what we always looking for. And the idea here, the spoilage supposed stop means we need to inactivate or kill the bacteria, microbes, which is responsible for the spoiling or damage our product. So it is also linked with the, we need to maintain the product quality as well as not to compromise the safety side. So that all included here. So we advocating from the last time also advocating with the non-thermal one. So now rather than repeating this one, we come here for the thermal and non-thermal one. So for the mostly products, whenever looking for the product with the maintaining the good better quality, mostly technologies they're looking for non-thermal one, and of course there are number of technologies even for non-thermal, and every day we can found here some changes, some ideas will coming on that one. So in the nowadays we discuss about the cold plasma irradiation, other parts, and now today we are looking for the techniques with the ozone. Ozone, how the kind of application even for the food preservation, even if you see here is work like a sanitation for the food plant products, even for the industry where use of wastewater and treatment, that ozone treatment now they are commonly used here. Now come here for the food decontamination methods. For the fresh foods, even the cut foods, they are commonly used. Even the, as we mentioned, not only the fruits and vegetable sector, you can go with the grains and cereals for this one. And they have the properties for sanitation on the surface side. Even in the food industry, what we looking for this one purpose like a chlorine and things, and it has a better effect compared to this one. So even in industry side, they looking at commercial application, and particularly they looking to replace for the common sanitizing agents. So mostly in the industrial side, that's a chlorine they are commonly used. So this is quite a environmental friendly application and even maintaining the better quality product. So this one again we come with the ozone, particularly I come with the historical part here. So around 19th century in 1840, so that was the first time they found here, that is the gas actually, that may be ozone, in, not application side, that may be the O3 we can utilize for this gas for the application side in the food. So for the ozone, now we get it O3 means O2 plus one unstable bond, that's O, that's become our O3 here. So for ozone properties, they have melting point and boiling melting point up to 112 and melting point about minus 193 degrees Celsius, and the properties of compared to O2 is a completely changed. Even is the density of ozone is 2.14 gram per liter at 0 degrees Celsius. So even the gaseous ozone, what we consider is more denser than the air. So we consider is a triatomic oxygen. That's so when we say the O3, that's our triatomic oxygen, and it may create in atmosphere by lightning in the sun rays. Okay, and naturally even in the sun rays, all ultraviolet rays, what will happen in the sun rays? It will break down the bond between O2, and that we have those two weaker bond, and then another O2 they try to attach one like unstable way. Of course, that's what we is talking here for the natural side. So it has larger oxidation potential. That's why it's used as a sanitation process for the mostly fruits and vegetable, and it has also have the characteristics like a strong and highly reactive oxidant. But for ozone, we can come here one part here. We cannot buy the ozone. Okay, we need to generate the ozone on site. So you cannot see we can buy from market or available in the market. So ozone mostly whenever we like to apply the ozone, it's supposed to be generated on site, and then we can apply the ozone for our application part. So we create the ozone here by two ways: corona discharge or UV rays, and that's commonly used. That's creating the ozone with the ozone generator one. So when we generating the ozone in the process, it's not only the O2, O3 we are getting here. With the O3 we have the another additional substances that may be additionally getting, that's including hydrogen peroxide, nitrogen oxide or nitric acid, with coming with this one. And Particularly the O3, when we say here for the ozone formation 1, that's we have O2, that's we can diatomic because it's a 2 bond, 2O, and one when we break it due to sun rays or even from the UV rays, and that's what we say the unstable one, and that make us triatomic molecule. And that's what we mentioned here, that is getting from the electric discharge or electrochemical process or our corona effect, actually electrical corona effect, to making that O3 here. And these methods commonly used, particularly mostly what we see in the popular one like a electrical corona effect, actually that where the corona ozone generator, actually they based on this one. And again, whatever the food quality, again you concern here, because even I are talking here the FDA again here, that's 1997. After ozone we identified 100 years back, that may be the agent that may be used for the food preservation. They recommended now you can use the ozone as a agent for the food preservation. That is the safe according to all guidelines to application from this one. So mostly times we are aligned or food research, food safety research, whatever the recommendation by the FDA. And even this one again after latter stage, it's you as even you can use that ozone as like a microbial agent, okay, for the storage processing of the foods. So idea here to eliminate pathogens, sanitize the food, even in the process side, in the plant side you can use that process. Okay. Now what became the ozone here, one wood is which is a highly unstable, so it will rapidly not connected with this one, it would connected directly contacted with molecules from the food materials, okay. And in ozone side, of course, this also I mentioned one time, that's we need to make it in the places itself. And for the ozone, again the properties, the ozone commonly is a gas, okay, it's a gas, and which is slightly soluble in water. And for because they sometimes the ozone properties when they're using for the food quality and things, they maybe look for this one, as ozone degrades very faster one, but its half-life of its gaseous state, half-life of the ozone in the gaseous state is higher than aqueous state solutions. And particularly the ozone in unstable, and that's the benefit we are taking for the process actually, because it's unstable one, but they are more unstable in the air, stable in air but high in the water, actually high in water. Even in the byproduct, what we get at the end, that atmosphere oxygen and its residues, there are some process at the end. After the process happening, our ozone treatment process, it may return to the air without making harm. So mostly we consider that process is an environmental friendly process as well. Again, one characteristics, this one for the ozone air, ozone we can make with the two part, with like a air or the pure oxygen, okay, with the pure oxygen. And mostly in the process, even in the if you the ozone generator, when we use in the air, the idea here to get a dry air, actually dry air, and that time the ozone is the blue gas, is a color is looking like a blue. And when you have the pure, or when you're making the ozone from the O2 direct, oxygen directly, is a colorless, So when we consider here ozone is highly reactive, the idea here because it's unstable. One bond is unstable here, so mostly of course it will getting on site, that's the reason. And mostly studies we can see here there is a concentration as per our requirement, what much doses we are using for the product and for how much period. So both way we are looking here depending on the concentration and for what purpose we are using. We are looking for the sanitation or processing or what were the requirement for the product, for looking for extension the life. So here again they make here when we generating the ozone that UV radiation that have the nanometer length just to breaking up the O2 to separate O2 and one bond may be attaching with another. So when it passing through the that oxygen molecule with the broken up and then that joining with the another O2 directly, it's like a O3 process we are getting here. And particularly when the factors when we consider here to generating the ozone, that's what the voltage, the frequency, discharge gap, the thickness, that's particularly what we say when we generating the ozone. So mostly the ozone what we presented two ways, one with the milligram per hour or per ppm, parts per million. That's a commonly representation of ozone concentration. And what again I mentioned there, one part here, when we are generating ozone from the air is supposed to be dry up. Okay, if this air is not dry, there is a chances of nitric acid formation. To avoid that one, we need to make it dry. And of course, this was in the when we making from air is like color like a blue. If it's a pure air, completely colorless. Ozone is completely colorless. Then what we say here, ozone's because we are dealing with the ozone properties, it has a lower partial pressure and but it has highly soluble in water compared to the air. And mostly cases when we generating the ozone at low temperature and higher pressure, it may be give you the concentration of ozone is a higher type. So in ozone production, particularly, they look at the condition before we are generating ozone. What is the environmental condition? What outside temperature? Because we consider here low temperature, that may be a good part there. Then what type of food material we are targeting? Okay, is mass, volume, how much concentration we required. If it's a product with a high water, means it has a water activity higher or lower, how much microbial load on the product. So all the factor we consider actually how much ozone we can require or what may be our dose for ozone. Then what ozone we are getting, actually we are getting the ozone from where we are getting, and then the quality of ozone we are getting from air or getting from the oxygen directly. And then we look here what type of the doses based on our treatment. Actually finally you are going for sanitation or processing side of this one or killing the microbes. So it's just like a simple process. Maybe we have the commercial one who are generating the ozone setting one. Now here from the oxygen tanks or sometimes maybe directly from the air. Here we can have this one. If it's oxygen tanks, maybe you are getting the pure oxygen, so you get the ozone. Otherwise you have the oxygen air where we need to dry it up. in the system to pass into the generator. And then we have the treatment chamber, but now here we have the ozone destructor actually lastly, because after processing this one, there may be some component that may be coming with the oxygen that may be destruct here before passing the pure air to the environment. So just to getting here the purpose of that, here full oxygen concentration, like the generator, we have the O2 generator box where we are getting this one. One is we have the cylinder of oxygen from where we are, otherwise the air. Based on the getting this one, if you're taking the ambient air, our first idea is supposed to be clean. So whatever the dust particle is supposed to clean up with the filtering one time, and then we have to remove, means dry up. So it will help here to possibility getting the nitrogen there. So just to idea here, removing the nitrogen, so percentage of oxygen supposed to be increased here. And of course when we are looking for drying, so is dried at desired dew point temperature of below 4 degrees Celsius. So even in the generator there are two processes commonly used. It may be UV generator or coronary generator. They are the most commonly used for the ozone generator one. There is a flow meter just to get here idea what is the flow of oxygen we are passing and at the end, and what is the concentration we looking for the oxygen we are supplying here. The treatment chamber, where once we get the ozone for the treatment, where we are keeping the fruits, vegetable or any product for the processing one, we are passing the product from the top and getting back from the treatment. Now always the challenging here ozone analyzer actually. The challenging part here because what is the concentration that is absorbed or utilized during the process. So how much that is absorbed and how much leave the treatment chamber, they need to measure this one actually. So that is utilize ozone for this process. So there are some techniques, some methods to measure this one. And last one, when I say the destructor actually, because it's like outlet. So whatever the excess ozone that is not utilized, that may be destroyed, and the purpose here to clean up the air, because before going to the environment it's supposed to clean up or decontaminate the air and then pass to the environment. So for the ozone one, the ozone measurement, there are different techniques different measurement methods where to measure ozone concentration. So one is iodometric methods. So with the help of pre-iodine plus ozone plus air, we are looking here to get the concentration that is utilized for the process. Another one like indigo sulfonate methods, sense methods, and UV absorption method that is nowadays used with the UV. Okay, so they use our Beer-Lambert equation. Those who are working the UV, this is a similar equipment where we can use for this one. Just to look here for where the molar absorbability for this process about 2900 per meter, and this is a standard protocols or standard equation just to measure the concentration, which may be little challenging how much ozone is utilized for the processes. Now the interesting part with here how ozone treatment works for this one. Now we get one idea here when we discuss this one with corona discharge or UV rays, which is helping here break up O2 to make the new bonding. So that unstable, that's a broken single O, try to connect here with this one, but it's always the weaker. That's why we say here unstable third oxygen atom of ozone, which is the unstable, and that is the helping here to decontaminate or going for the processing side. What will it will do here, that unstable bond whenever contact with the material, that's any organic or inorganic molecules from the food product material, with the contact with due to oxidation, they are try to destroy it, and that is process of destroy that one through the oxidation. Another one, particularly if you see in the grains, if they using for the grains for O21, if the insect is there, okay, sometimes the insect we say you have the issues. If the insect inhales that unstable O, unstable, it will die actually. So even they are using for the grains. And that big breaking that one and making that big bond always utilized here. So the oxidable substances, maybe they are with the algae, bacteria, fungus, virus, they are contacted with this one. So when we look for the how it affecting and killing the microorganism, just to get here one thing here, because ozone, what we known for this one, it has high oxidation potential. That's one of the characteristics for the ozone here, and that is helping here to lysis the microbial cell. Microbial cell, that's a directly target on that one. So directly killing this one. So there are involved two basic mechanisms for ozone destruction here. First one, that ozone oxidize the sulfaryl group and amino acid, first one, and then the ozone oxidize the polyunsaturated fatty acid. Particularly if you consider this way, actually our unstable bond, they may target with the SH group with an amino acid is the first site, and second one like the enzyme and protein site. Now when in the process of the oxidation, there is a cell breakdown and leakage of cellular contents and causing the process of oxidation for the unsaturated lipids of the in the cellular membrane, and this may indirectly link here date of cellular date. Even they come here with the ozone sensitivity is quite higher, and there is a chances even changes in the viral protein code even during the processes. So the process what we see here, particularly in the microbes side, we can say the two steps. First is our SH group and amino acid, and secondly with the peptide proteins and linking with the cell date. Now in the ozone, because it's like a non-thermal, quite people looking for the environmental friendly technologies. So mostly food application, starting from the spices up to the dairy industry, they are quite popular. Even some applications, because the spices why we using their volatiles is quite important. The volatile components incorporated to this. Dried food, grains, meat, poultry, food, seafood, even the liquid as a dairy. So its application is wide. Nowadays, recent one, rather than fruits and vegetables, we can found quite long studies coming on the cereals and grains actually to apply in the particularly the ozone treatment. And yes, it has the capacity, it has the maybe looking for potential, because now in the industrial side what the sanitizer we are using, like a chlorine stream of hot water, maybe coming period we may have the potential, even it has performance wise, when I check it's more than 1.5 times better compared to chlorine, the performance of the ozone here. And even it is a safe product to use, and even it's a natural considering here or cost effective, chemical free, so it has, that's why it's maybe getting the attention nowadays actually ozone treatment for this one. And it shows here when with the unstable atom contacted with the product, it has able to kill or inactivate, including the all the parameter, all the organisms from bacteria, fungi, yeast or parasites. Even in the product, particularly you have the one thing is it may be working at the surface as well as in the inside the gaseous state or in the dissolve in the water, because we see that there is a properties of the ozone, it may dissolve in the water properly. Now there are some studies, particularly ozone, they come here with the treatment, and they come here some particularly in the research side, mostly they look for the ozonated one. One is the what we more interested about, the what's the concentration we are using, okay. And when they use for the cabbage here, the concentration is 2.3 milligram per liter, and but now challenging, because as a researcher what we always do is to optimize our things. So 6 minutes they found optimized condition where they able to reduce all the bacterial count by 90% with this process. Even for the grapes, now one thing you can check here, every product to product there are something we may check here, that's a concentration we may utilize as per our requirement actually. And they look for the grapes one, for the bacteria, fungus or yeast one, even reduction increasing up to 8 milligram per liter, but now the timing is reduced up to 20 minutes. So even the ozone they are used for the treatment for the surface treatment, it will helping here deterioration of the fungal from the surface from the product as well. Even for the onions, nowadays the ozone is commonly used, particularly because simply you come here, whenever bacterial counting we are talking about is has a property to make it down, and not major change or changes happening with his composition as well as the sensory properties. Even for the dates, they have good one, like they show the concentration in the 5 ppm to maintain the quality for the dates. So for the berries and for the apple even, so most times as we mentioned one again, the units we can represent it for the ppm or milligram per liter or meter cube. And there are two things actually, whenever you like to do in the research in this one ozone state, we like to play or understand the concept, what is the concentration. Of course it's linked with your purity of the ozone, it is coming from the air or from the oxygen directly. What's the concentration we are using and what's the timing we are using, because we like to see the effect on whenever it like sensory characteristic, physicochemical changes happening with the product, or whatever the microbial or bacterial things, how we can control with the help of this one. Then another challenging part with this one, okay, for the fresh produce, with the uncut one. This is commonly used, but again the challenges come when we look for the cut one. The process, oxidation process, biochemical changes happening very fast, and controlling with this one also the challenging one. And there was the study particularly when they look for the fresh cut apple and onion slices, even they come with the bacterial as well as the textural properties actually that may be maintained throughout the process due to ozone one. Even for the chopped peppers, and this one for the meat one. But when they do this one, they look for the higher temperature compared to not with the lower storage condition. This one, even just to looking at application for the wide variety of the food product, even the fish fillets, to controlling the microbial flora. Then for the grains, as mentioned, it's a grains is quite common use, particularly maize, corn. There are, you can find it a number of studies coming on the corn and even our rice actually to maintain the quality, because it's a main concern with sometimes the changes in the biochemical, but even the insect, okay, alpha toxin, that all the things we can control with the ozone treatment. Then for the flours, dry powder, wheat kernels, and even the liquid product for the milk, even they use the ozone for the treating the product. Even the firstly when you see the cabbage one, when they look for the fresh cut cabbage, always we're dealing with the post harvest food side. When the product we deal, if it's a complete cabbage, how we facing the problem for controlling is maintain the quality, and when it's a cut one, it's a completely change the product characteristics. Okay, because what we aware this one, as soon as we cut the product, a lot of biochemical changes happening. The respiration, transpiration, ethylene suddenly extend by many folds actually for the processing product. So when they using the ozone here and looking for the different doses from one to different timings with the ozone, keeping the similar dose, and they looking for the respiration and transpiration, and they found it when we treating for the longer period, it giving that the better result in terms of respiration, ethylene production. At the same time, acceptability, but acceptability you can see here little bit contrast result actually. The acceptability they found by the appearance side from the consumer side when we keep it for the 5 minutes. However, in the respiration and ethylene production reduction we get for the higher period. So we need to combine that all the outputs actually when we looking for our next research, particularly that area. And of course the storage goes up to 12 days, and it's a challenging for those who work in the fresh cut industry. We can understand this is a challenging task to extend the shelf life for fresh cut product compared to complete one fruits. Even for the onions, for the slicing one, they found here with they come with the different treatments, different timings, 1 to 5 minutes, and of course whenever we go for the lower side, means higher side of the period, rather than changing the dose, we can control the chlorophylls, yeast, and even the respiration. But you can found again one thing here, the chloroforms and yeast is not directly linked with the respiratory one. respiratory one with the timing is also changing, what we are expecting here. Then again for the fresh cut lettuce here, they have looking for the gallic acid, lactic and aqueous doses, that's combining with that one, going for the directly ozone or maybe pre-treated the product, and how the result will coming out that one, or weight loss or electrolyte leakage for that all combinations, if it's working or not, that because it's just like ozone plus we are another treatment we are doing here. Even it's for the leafy vegetable like a spinach, and looking for the characteristics, particularly chlorophylls, flavonoids, and how it changes with the ozone one, and with the storage period up to 12 days with the spinach, they are looking for this one. And sometimes we come here with this one with the when we use the chlorophyll one, that is a high maintain with the ozone treatment. Similar for the apple slices for ethylene or PPO activity for this one. But for this one, when we are looking for the product one, what is important here, it's supposed to link with the overall quality. Overall quality, they come here sometimes with the sensory one actually. Is the technically we see the product is safe or something, but what about the physiochemical properties that's accepted by the consumer at the end? Even for the bell paper, now is this one, they try to link again with this one. Sometimes rather than going for the ozone, we treated the ozone, and why not keeping it the regular storage condition, then it may be linked with a MAP or CAP or any cold storage condition with the temperature management things and how the effect is changing. So even it is like a hybrid system they can make here for that process. Even for the kiwi fruits, we're looking for this, and the mango. For mango, the storage period what we have in the ripe mango is about 1 week to 10 days. Okay, we can store it. Now the studies, they able to extend up to 4 weeks, but the treatment what we see here, the quite longer period actually, quite longer period for the ozone one. Here just to check here, there was the same timing, but they try to change the doses. They try to change rather than changing a timing, now change the doses of the concentration of this one, ozone one, and here little bit contrast result. Sometimes we found that treated with higher doses and with the lower doses, not directly significant way coming the result one. Like if you see when I say this one, particularly this one, when we have the lower dose, but when it coming for the last days, it is little changing with the weight loss. It is accelerating on latter stages. So when we come with the process of when we using for fruits and vegetable for ozonization, there are of course there are pros and causes for every processing system when we selecting for the product, and mostly for the it has a capability, particularly when we is looking for the positive side, it has a capability of highly oxidation, and that's why in coming period when we say the industry is looking for something replacing maybe some times of chlorine or another methods to the ozonization, and even it is helping here the product to stress abiotic stress spot easily control cell wall activities resistance for the one target here mechanical damage actually whenever handling that one. So just considering that the up to certain level, because what we're talking about initially mechanical damage at higher level is difficult, but the cell will become little stronger or enhance the resistance actually, the preservation of vitamins, and at the end it will not keep any residues, so the air can be reutilized in the environment. So and processing time also not faster, processing time faster, so you can do the process very faster when, and what it's doing here is a control or stop the growth of microbial, enhance the some antioxidant defense metabolisms to prevent the product here. Particularly one supposed to technical side when we say there is some negative points as well, we not say it's as the agent that's unstable one is a quite active one, okay, so there is chances to processing very faster when sometimes desirable or undesirable, then sometimes mitochondrial oxidative stress happening with the product, and when it's looking for sanitization of surface one, so most of the times they recommended not for this one, so they consider it may be damage internal cellular integrity. Sometimes some studies actually they come with some sensory, because we found some studies actually in our cases the characteristics of respiration, ethylene and others are for some condition higher, but acceptability score by the sensory it was different, because sometimes the physical appearance from the product is not up to that mark, sometimes changes in the color with the when we go for the higher doses one. And so the again what we say the aqueous form of ozone is less soluble in water, so it has a quite shorter half-life of the product, and it may come with when we use the not good quality water, but particularly in the processing side when we see here they're taking that one when it's like used for the water treatment, okay, water treatment, but in the food and vegetable industry when we're looking for what this may be overcome easily. So in when we're looking for that ozone side actually, now the industry what they're looking at as a consumers they come with the environmental friendly, not treated with any chemicals, not treated with the chemical, that's what we're looking for the good quality product, and they may be getting the popularity coming days actually. Even last decade, not a decade, 10 to 15 years, the research side wasn't getting the whole popularity. At the same time, industry we found lot of industry involving in that one, the processing unit applying the in the sanitizing side or processing side for the product, even for the range from the all type of food material, from the grains to the meat to the fresh foods and even fresh and cut product, even the flours. So we stop here with this one with the application side of the ozone, okay, and thank for your time again.
Good afternoon, sir. My question is, how ozone affects the polyphenols in fruits and vegetables?
Particularly, you were talking about the polyphenols things actually. So, when we say here, mostly is, the ozone is we are using for the surface treatment, okay? surface treatment. And with the surface treatment, we're not directly coming in the polyphenol, and this one, not direct studies with this one, what we show here. But the processing, how is happening with the product, with the molecules which is responsible for PPO. Okay, this reaction with our unstable oxygen, because if you consider the reactions, what will happening with the all molecules which is responsible for the changes.
Okay. Sir, one more question. Oxidation of polyphenols are not favorable to the vegetables and fruits. So how could ozone be advantageous?
I'm not.
You are not audible, sir.
Repeat one time.
Sir, oxidation of polyphenols are not favorable for fruits and vegetables.
Yes.
So how could ozone be advantage for the use for users?
No, but the purpose actually, for we are using the treatment for we have the different target actually.
Okay.
Sometimes your target is like looking for the microbial. If your target is PPO, maybe not this one, but if your target with the microbial load to stop, and it is in that link with your PPO activation. So the particular the technology what we are looking here, what we are targeting actually.
Okay.
Yeah.
Thank you, sir, for such an insightful session. My question is related to, as we know, ozone is naturally available in gaseous form,
Yeah.
and here we are using ozone-treated water. So basically, I want to ask, can we, like for chips and all, we are using nitrogen flushing. So can we directly use ozone for those kind of products?
Particularly dried product is maybe possible, because now when we're looking for some dried grains, dried spices, rather than directly flushing this one, but I maybe it's a very strong statement to tell you that some studies are basic studies for this one, but it may be possible because the moisture content for your dried one is also low, and your target is for the keeping the product whatever the nitrogen flush, but it's a possibility to use this one actually with that product. You can use this one.
Thank you, sir. I have another doubt. Sir, we are using this for sanitation and decontamination also.
Yeah.
So basically it is affecting the microbes.
Yes.
So what are the chances of it affecting other biomolecules, desirable biomolecules of our food product like proteins and carbohydrates?
Because mostly the studies what we see in the ozone, you not documented that part that intensively. It's like a surface decontamination, that is the one surface actually what we're looking for that one. So if you see that this way, there are not much documentation, particularly this one. So
For some products we have used slices also. So
yeah, this may be for the fresh product, that's this one, but in the processes where we are the fresh cut product, there is a chances to affect this one.
Thank you, sir.
So it was an insightful session, no doubt. So whenever we talk about ozonization, right, so we try to replace the chlorination, right?
Yeah.
So both beings the radical,
Yeah.
like we are using chlorine radical in chlorination
Yeah.
and oxygen radical in ozone,
Yeah.
right? So my doubt, it's not a doubt, I want to actually know your view. So which you have well covered in the pros and cons slide.
Yeah.
So one of the cons that which like you have mentioned is discoloration, right? So when I actually treat my or wash my vegetable samples or cabbage or something with ozonated water, so I am actually letting the oxygen radical come in contact with that particular vegetable, which activates lot of enzymes like polyphenol oxidase and peroxidase. Degradation due to in the color and quality with that enzymes is much more than the effect of ozone we see in the sterilization or maybe decontamination. So how far you think, like when I go to some industry and tell them to replace the chlorination method which is not activating these enzymes, how far like we can do it, or if at all we have to suggest them, so what additional technique you suggest to do in parallel with it?
Because when we look for the when we compare with the chlorine, actually you are correct in that way, because some enzymes and the colors that maybe we are getting better with the chlorination actually compared to when we take the ozone one. But when we're looking for what's the targeting product in that, if you are maintain or you are looking for desirable changes with the enzymatic activity for this one, that's also one thing. And another one, like we try to come with the chemical pre-process. So that way it will go actually. Not directly in that way we can maintaining the chlorophyll or color with what enzymes we are activating, deactivating with the processes. But another advantage, if the product rather than chlorine, and we would like to away from the any chemical one. But it may be how some industrial doubt, particularly when, because they want to sell the product in how they want, yeah, look like more changes or desirable changes with this one.
So do you have any experience with some similar for the industry, like which they have asked, to use the ozone, and then they have maybe to resolve the problem of
And
discoloration?
particularly only what we have some experimental side one, not with the industrial side. That's why I concern with your point. That is the something valid point even.
My next question was with respect to slide number 25. So in which you have taken, this is a research study.
Yeah.
So in this you have taken overall quality score.
Yeah.
And as we can see from the control samples, it is actually linearly getting decreased, right? So which is a bit of, I mean, how like whether they have used the the samples with some kind of packaging or something, or because it is very much linear. And with respect to same results in slide number 29, this was not linear in control samples. That was with respect to apples. So how, like, both of them is a bit
Actually, the things here with the storage conditions, okay, for both cases, it may be different actually for both cases. Not about the treatment, okay, treatment time, storage condition. It's like a cabbage, even in the, what we say, the particularly apple, there is a chance of getting oxidation very faster, and this may one reason here the control samples overall quality loss is complete decline. Okay, of course they also decline, but it's a very steadily decline this one. And in this case actually the expertise score when we see here is decline with the time with the after 8 days. And again one thing you can see here with this storage study just for 12 days, okay, and however the apple study is a double, I believe. No, it's also 12 days actually, but reading times, okay, just come in this point because they check with the similar way ethylene and that part, and ethylene reduction is fine, but your expertise score with this may be linked with your physiochemical changes, and oxidation may be quite higher with your product with the control situation.